This is lecture number 22 in the peer-to-peer book series. In this lecture, we will be looking at another alternative design for overlaid multicasting. In the earlier video, I had discussed a design where we were using neighbor tables. So a node, if he wants to get a feed, he was having some neighbor tables. So these are the neighbors who are listed in neighbor table. He was sending a broadcast to these, and these broadcasts will then keep on moving around, and somewhere when the source is already broadcasting, so this will go to their neighbors and so on. So there may be multiple places the request may reach. So for example, this reaches here where the feed is already available, and another one signal reaches here. They both will start giving the feed. Then we had decided that when the feed is actually being received, for example, say from two places, from this as well as from this, only one of them will be accepted, other one will be rejected. So in a way, the distribution feed actually reaches to the seeker, the guy who is wanting to receive the feed. But there was one problem which was also evident at one of the place in the lecture, that if, for example, a node is only allowed to have two neighbor tables, so these guys now having each other. Okay. So before even this guy joins in, this guy is getting a feed from somewhere, and this feed is being, for example, now being received and given to this person. When this guy comes in, these three guys will update their neighbor tables, and when they will actually, this guy will try to find out, it will find this is a more lucrative option to get the feed. So it will say, okay, give me the feed. So feed is now supposed to come this way, but he will also relinquish this master node, and ultimately all three will stop getting the feed. Okay, there was this particular possibility which exists, and in that case, when the moment is figures out that feed is not coming now when I left it, so it means there is a cyclic thing, so I should actually not subscribe to the new subscription. It will relinquish this one and actually join back this particular feed, and this feed will now again will start appearing. Okay, so this will become correct, and this will again start appearing, and now the feed will go in this fashion. That was the way this problem can be solved. But now today let's look at an alternate design where this problem will not happen altogether. Okay, now this broadcast, the join which is being sent as in the broadcast packet to everybody from a person who want to join, because there can be multiple guys who are trying to join simultaneously, and these packets will actually be forwarded, they will not be discarded. While even joining with only one person, everybody could have actually become may start receiving the feed, because its joint broadcast will be actually received through everybody who is not even getting the feed now. So the alternative way is that every node which joins will find a bootstrap node. So ultimately, when the source is starting all alone, he is the only guy in the bootstrap node, and later on there can be multiple of them. So this bootstrap node will mostly be listed in a stream advertisement, so which will contain a stream ID. So now you will identify this one. So remember, this particular information is important to join. So there is now bootstrap nodes, maybe one or two. So in worst case, it will be the source itself. So source, if has a provision for 4 or 5 guys for a further distribution, it can actually put a list. And of course, this basically the thing will be there, and of course in which layer this actually follows. So in which DHT layer, because that's also important. You have to join that particular DHT layer. Initially you will not be, you will be only in base layer or maybe some other layers depending on what services you are actually using to peer-to-peer system. So there will also be a layer ID which will be defined for this. Okay, so stream identity and layer ID will be having one-to-one unique mapping. So this source, this guy first of all gets a bootstrap node. So it will essentially put this thing in its own routing table. And since this S is in the routing table exchange will happen. The new neighborhood of S will essentially known to him. He will now start optimizing its routing table. S may not be the optimum entry. There may be other guys who are closer and who are maybe in the different logarithmic partitions. We are still doing logarithmic partitioning here. So ultimately it will build up its own routing table. It will also build up the neighbor table, which will be based on the proximity, the nearest proximity guys. And every time a routing table update actually have more than one option, we will be choosing somebody which is closer to us. It will be either through RTT test, round trip time delay measurement, if the guys who are options are not in my neighbor table. If they are, I know already which is going to be the closest one, and I will pick up that. And of course now this way the routing table and neighbor tables will get updated. Now one more thing which we can actually now innovate. Earlier there was only one media stream which was coming. So it was audio, video, can be a slideshow or whiteboard, maybe some signaling, but all this is coming as one single layer. So either you get everything or you don't get anything. We can now innovate on this. This is actually based on layered multicasting. These are basically based on layered multicasting. Now what happens is in the network, congestion can happen. So you are actually passing a traffic to this node and this goes to another one, this is going through a router, and there is a congestion in the network. So network capacity has been reduced. So there is no network capacity is less. So in that case, what should be done? So only way you can actually handle it is by reducing the traffic which is passing through this. So everybody whose traffic is passing through this has to reduce the amount of traffic and match the whatever is the demand which you are putting on this particular bottleneck link to the capacity of this bottleneck link. So you cannot actually exceed that. So you have to drop the things. Now this actually is feasible in TCP. TCP, Transport Control Protocol, uses an algorithm called TCP Reno. So it is basically a flow control mechanism, but it also does congestion control. Okay, so here there is a transmit window and there is a receive window. Okay, so transmit window is what is being adjusted. Periodically you start with a small transmission window and you find round trip time in the acknowledgement. By the time you get the acknowledgement, that time is within limits. Then you actually increase the transmit window, you double it actually. So this keeps on growing exponentially first. Okay. At some point of time, it will then become linear after that. And if you actually start getting losses, that time you will then further immediately reduce back to the original minimum value again. And this value will be the half of this value. Whatever is this value, this half I will decide. Again, I will grow exponentially till this, and then there is a linear thing. And if my receive window is actually much larger, then only these oscillations will start happening. Okay, that's what happens in TCP. So this time probably it has gone here, so its half will be somewhere here. So it goes back and then transmit window grows, and then after this it will increase linearly. So this periodically happens. That's what how the transmit window is controlled. But my receive window is below this point. If it's somewhere here, so then transmit and my actually sending window in which I am transmitting without waiting for acknowledgement will get stuck to this, because that's the minimum of these two, and I will keep on operating here. Okay, this congestion control will only get triggered when my receive window is much larger. I am not limited by the receiver. Okay, so average value will be now matching towards the whatever is the network capacity. So this will be done by everybody in TCP. But incidentally, for all our media transmission, for audio, video packets, because I don't want reliability, if a packet is lost, it's lost. Because even if you retransmit it, it's of no consequence by the time the time has elapsed. This utility. So for UDP, we cannot use this algorithm TCP Reno. So in UDP, what we have to do is, I can actually now say, okay, there is a base layer which is signaling. So signaling and some basic information. Maybe after that I can send an audio. So audio communication is important. So audio goes in another layer. So when we use IP multicast, we actually give separate multicast addresses to these. And depending on if you are not getting all the things very nicely and there is a lot of delays, you are getting gaps, you actually leave the certain upper layer multicast groups and ultimately limit yourself to something which is going to give you the best performance at your playback. So you may be happy only with the audio coming in, you don't want a video to come in, you may drop it. Then video's base layer, this will not give a good quality video, but which is fine, you are happy with it. Maybe if you have still bandwidth, you can subscribe to even layer 2. So video quality will improve and you can keep on doing it. And there may be nth layer, which is the last one. So when you subscribe to all these layers, your audio is good and you get a high class, high definition video. In fact, ultra high definition you can get. So depending on what the network congestion, you will start actually either joining or leaving. That's what is going to happen. So normally if you are happy, it means your things are satisfied till this layer, and if you are happy for some time, then you make an attempt of joining the higher layer. And if you remain happy, you just again further make an attempt for the next layer, otherwise you fall back. So normally you start oscillating between layers. So because you become unhappy the moment you join, so you leave, remain for some time, again make an attempt, again you keep on doing this. Actually that's the only way you can figure out what is the exact, how many layers you should subscribe. So this is an experimental thing. Another alternative way is somehow you make an estimate of the bandwidth and you know how much is required, and based on that join only that much. And when your estimate says bandwidth has increased to an extent that next layer can be done, then only make this attempt. The chances that you will fall back will become less in that case. So both strategies can be used, but this is an IP multicast. Now even in this overlaid multicasting, we are sending these packets which are like UDP, and we will be using layers. So now when I am using layers, it's important that in the broadcast tree, when source is doing, so all layers should be transmitted. This guy should be able to receive all layers. Okay, so this is some node 1. There may be another node is there, so this also should receive. So as you go further down and down in the tree, the depth of the tree, so then the number of layers, the capability here should be maximum. Here can reduce, here it can further reduce. It should never happen this guy has the full capability of transmitting all the layers and this guy can only transmit the base layer. Now this does not make sense. A lot of people will suffer. Now this we can handle by using again a reputation management system, which we had talked about in the previous video. Now how the tree will get created, that's one of the questions. So in the earlier video, the broad join was actually started from here. Receiver, the source was never bothered about it. But we can make a change here, which we have planned to do now in our Brihaspati 4 design. The source actually sends beacons. So beacon is a special packet. Okay, beacons are broadcasted periodically. So advantage is that your broadcast routing table will not be that complicated. It's only one source which has to be taken care of, not multiple nodes which are trying to join. Okay, beacons are broadcast periodically, and every node will have, for example, these beacons are being received by these two nodes. So these will have a broadcast routing table which will say that it has come from source, this was the sequence number, and this is the age. So that's what the beacon will contain. So every time sequence number has to be incremented, it will never be decreased. So in worst case, this will go from 0 to 65,535, assuming that I am using 16-bit for this count or sequence number, and then it will go back to 0. That's why age is there. So if an entry is not being updated for a certain time, this age basically expires, I will purge this entry. So even with the 0 sequence, something will come, I will then accept it and will forward it. So now the packet will be coming here, packet reaches here. If there is, for example, a connection from between these two, so as a consequence one packet will come here, they will make the entry, then they can actually make the broadcast in this direction. This guy will simply discard, this will be also discarded because the entry already exists in a table here as well as here. So these guys, two guys, so these can actually further do the broadcast and so on. Okay, as a consequence, you will get a tree getting created from source. Okay, but only thing I am assuming there is a mesh. In fact, technically we do actually have a mesh because of the routing table being managed, but that mesh is not on the basis of what is the capacity of a link capacity of a communication link between two nodes, whether it can transmit all layers or not. It's not on that basis, it's based on the node IDs basically. So if I look at the routing table, okay, and at the some neighbor table can also be there, so proximity can also participate, but this cannot guarantee this kind of thing, so I have to build something extra. So we create a third table, we call it an overlaid multicast table. Now this actually makes protocol slightly complicated, but this is going to work as per the current understanding. And so we call it a OM table. So this need to be maintained. And this will be in addition to RTA, NT and OM. So this basically will now keep the record of who is my parent. So the node ID and basically endpoint address for that, and who are my children. So all of your neighbors some of your neighbors may not be there in any one of them. So it is possible, for example, S will be in the parent of N2, but N1 will not be in the child even if it is connected. Similarly, N2 will not be in the child entry of the N1. So there may be some other nodes which may be here. So there may be nodes like this. So this guy will only be a children of one of these two nodes, not both of them. Okay, so some of them have to be discarded. In fact, there is a protocol which we have to, when this broadcast is done, so we have to, from whichever route I get my first packet. In the beginning, for example, say this table is not being constructed. This table is empty. Okay, so source will now send a beacon, and because of routing table, we are sure that every node is participating in the network. They are not disconnected. Okay, so and of course we can also allow all the nodes in NT2 also be used for doing this broadcast of beacon. So whenever a packet is going to be received from a source from a previous node, so that node ID, so node from which packet is received, so once I am able to create this OM table, then of course my broadcast of the media stream is far more easier. I will always receive the things from parent, and then I will pass it on to all the children, one copy each. That's it. Okay, and as children are going to get, they will manage my reputation, and I will always try to find out from my parent who are their parents, and will try to always keep on trying to attach one of them to get a higher reputation actually. Okay, so because if I am actually serving more number of children and I am serving more number of layers, we have now made the change that if you serve more layers, you get higher reputation. If you are serving less layers, you won't get higher reputation, get less of it actually. So we have changed that formula slightly in this case. So nodes from which, let's come back to the protocol here. The nodes from which packet is received first. So S can come actually from multiple times. This guy has got from here as well as from here. So whatever is the first, that will become the parent. Then it will actually, it's better to do some delay here. So then there will be a delay which will be inserted intentionally. By that time you may get actually broadcast from other nodes. So nodes which are, so initially you will keep everybody in the children, but you have still not broadcasted anything. Okay, but this children think we can have to keep on updating. Nodes from which duplicate beacons received are not going to be in child list. Okay, so and of course the moment you get a duplicate, you for example get a duplicate from here, you have already sent your packet, so you got a duplicate, so you have to discard N2. Okay, and if you have not sent this particular packet, because there was a more delay here, less delay here, so this packet was not sent, only you could receive this one. You need to send a NAC so that N2 will also not keep you in the children list. Okay, and if NAC is also received for your broadcast, then also you will not be. So you send something, you got a NAC, other node should not be in the child actually in that case. So in fact, these both sides the packet going will never be happening because there is a different delay which are randomly put. So it gets a broadcast, it is now delayed, this delay expires first, so it sends the broadcast, this figures out its duplicate, discards it and send a NAC. So when the delay will be over, delay which whatever you have inserted, you won't be broadcasting here, you will be broadcasting to other nodes, okay, and those guys will only remain in the children list, that's it. Okay, this way now you will actually form a tree. So this tree is what is going to be used for now sending the broadcast of the media. The media will always be coming from, will be received from the your parent, and you will be giving it to your children, to nobody else. In case your parent stops giving, okay, you have to essentially find out which is the best second choice of the parent if it is feasible. So you can actually keep parent 1 and parent 2. Parent 2 is the one from where you got the duplicate one, second duplicate, first duplicate actually beacon, and which was removed. So you can actually keep even parent 2 also, that's alternately possible. Or after some time anyway you will get a beacon from some other route, that will be the first one, and that node will become your parent and he will start giving you the feed actually. There will be some disruption which can happen, but with two parents being maintained, the backup parent, you should be able to handle this. And of course we also have a mechanism whereby you know that who is your grandparent. You always ask your parent who is your grandparent. This information should be there. So if you stop getting it, you just try to join your grandparent and get the feed. Most likely this guy has failed. Okay. If actually he is not giving it to you but giving it to somebody else, there will be a separate procedure by which he is pushing you out and forcing you to get connected to somebody else. Now, because we are using layers, I need to change my formula of giving the reputation. So ideally what will be happening is from source, the guys who can actually get all the streams as higher bandwidth with the source, they will receive, so they will actually earn higher reputation because they can provide higher capacity. The guys on the bottom side should be with lower reputation because they are either not feeding others, or they are incapable of feeding others, or they are getting very few layers, both. So my reputation has to be now based on layers. So if some node is getting a feed from here, and he is getting some layers, say he is getting k layers out of n, k out of n layers he is getting. So you need to send a message to the reputation. Again there will be a DST, separate DST network where the reputation of everybody will be managed. And again rule is that for every node there will be somebody responsible. We'll just compute the hash of the node ID and then find out here and then report the message, send the messaging. So again every 5 minutes you can actually, if you are getting the feed continuously, every 5 minutes you can send the update. We have kept it 5 minutes, but this can be any duration depending on the way you design, is your choice. Okay, but normally it's this guy which will figure out whether what all updates I have got in last 5 minutes. If you have already sent an update, it will anyway not be accepted. So it does not matter on you, it matters on the reputation DST, actually servers. So once the reputation server gets the message, what it is going to do is it has to compute what was the reputation earlier. So maybe our last reputation was built tau times earlier. Okay, and now suddenly there is a reputation has to be estimated now. So I will find out what is the decay in the reputation. So alpha has to be suitably chosen. Plus the new guys who are actually now giving me the thing. So I will now put A. Now I am actually doing something very interesting here. People could have thought because this was a very important thing. So A is a constant, again it has to be manipulated properly, figured out. And then what we do is we have the reputation of the node which is sending me and how many layers. So more layers he is doing it, his actually reputation gets amplified. So I get an amplification benefit in that case. Okay, if he is getting less layers or he is having less reputation, so these both actually technically gets multiplied. So it's better, it's always I think advantageous for a node to give the feed to the guys who are actually is able to receive more number of layers as well as they have higher reputation. So if you have multiple options available to you, you will tend to choose somebody who has a higher reputation as well as who can get all the layers. So as a result, the guys who are having weaker bandwidth and who are actually having lower reputation, they are not cooperative to the network, they will tend to go towards the bottom. They will tend to become leaf node in that case. So this is the only new change which has come in, which was not there in my earlier thing. So this is what is a change. And again, I will multiply it by 1. So, and then do the averaging. It is going to be e raised power minus alpha tau plus these are basically weights, e raised power a RRK. So this gets higher and higher weight if you get more and more feed. So this is how the formula gets changed, and now there is a new reputation value of the node which is actually feeding. So these are basically the receivers which are trying to send the updates. If some receiver is not sending correct updates, a feeder can actually kick him out. Anyway, he is not gaining anything out of him, and this poor chap has to then find out somebody else to latch on to. Okay, so he may ultimately go to the bottom of the tree and may get only very few layers, not a high quality stream. Okay, so for him the only best strategy to be cooperative and to send the things honestly, updates honestly, so that the other guy does not kick out. For the guy who is giving the feed, for him it's always the best to find out people who are having higher reputation and give the feed to him to the maximum, or the guy who can consume. He will actually try to optimize RR into K. So if he get many options, if he can give to feed to many people, he will compute RR into K for each one of them. Whichever got higher RRK, he will essentially always tend to give the feed to that person. So not only it's your reputation, but the link capacity between you and that node also does matter in this case. This was not there in the earlier system which I discussed. This ensures that my topology keeps on moving. Now interestingly, what we do is currently OM is not being used, OM is being just created, but OM now should change dynamically. So we have made one more change, is that we are going to create another part of the algorithm whereby that every node can ask for basically trying to join another node. That should be feasible. So you can always ask your parent about his parent. So you should be knowing your grandparent actually. So this has to be part of the protocol. If somebody is not doing, you will anyway will figure out some other better guy and will join him. Okay. So you will give him bad reputation. So it's better to always cooperate and give it. Okay. So whenever a node is going to be added to you, for example, somebody sends a request, you will also always send information about who is your grandparent. This information is sent. So he actually knows who is the grandparent and he can keep on attempting periodically to him. If he feels that this guy will be actually preferring him actually compared to somebody else. Okay. So this way this can upgrade by actually gaining in reputation actually. If you have higher reputation, you can join here. And then for example, this guy figures out, wants to kick this guy out, he will tell who are the siblings. Okay, he will tell, okay, I have all these further nodes which are there. Okay, so list of these will also be provided to him when he will be kicked out. So this guy can now join somebody here, here or here. It will get, essentially you are pushing this guy towards the bottom of the tree. And by giving the parent, you are giving him an opportunity to go up actually. So normally this will be done, because if you don't do it, this guy still can get the beacons from the entries which are there in the routing table and neighbor tables, because this must be there in those entries. So beacon may be coming from there. If it gets a beacon from somebody else who is better than this, he will try to attempt and join there actually, and will leave him. So it's better to give the parent actually, still you will at least get the feed. Okay. So even if this it does not tell about the parent, this information can be retrieved statistically from the neighbor tables or routing table based beacon broadcasts, because that will anyway will be happening. And additionally, when the beacon is going, once these tables are getting, this OM table ultimately will become different actually over time. So this may contain entries which are not there in RT or NT. So there will be some entries which are not present here, but they are present here. So that will happen over time. And important thing is that when you're kicking out somebody, you just give the list of all siblings to him so that he can try joining to them. But he will get downgraded continuously. So you will always trying to make an attempt to join somebody higher, and you are trying to essentially, whenever requests are coming to you, you will try to allow only those guys who have higher reputation into K basically. But K will come through measurement, that how much layers he can receive from you. So higher the RR into K, the better it is for you actually. Okay, so this is roughly what is the algorithm which can be used, and typically normally you cannot have large number of children. The more number you have, better reputation you will get, but after some time you actually normally don't get any advantage. So sometimes you would like to kick out the existing children and accept somebody else as your children, because he will give you a better advantage actually. So this can happen. So this actually will trigger a re-optimization of the tree continuously, and this will optimize in such a fashion that what we desire, that the links towards the source will have higher capacity and they can carry more number of layers, and they will, all the nodes towards source will tend to have higher reputation into K actually. RR into K, that's what will be higher for them, not RR this time, which was true in the earlier case. Okay, let's do a small short example where I will show that how the movement can happen. I am not taking large number of nodes. I am considering a chord topology here. So let the nodes be 4, 2, 3, 5, a 16-bit number, 0, 1, 2, 3. Then I have 9, 2, 3, 5. Then I have F, 2, 2, 0. Then 7, 7, 5, 3. AB02. I have just chosen something randomly and I have tried telling how this actually works. Let the source be actually now 4235. So if this is the source, and I am actually assuming this is a chord, but this is going to be possible with everything. With chord, of course, I am also maintaining less number of finger table entries. So a node will only be maintaining a successor, a predecessor, and a node midway across. So whichever is the root for this. So this node essentially will be pointed to. These three will be kept everywhere. So other finger table entries are not there. That's what I am assuming. So a node actually can do that if it does not have a higher memory space. So all node need not maintain. So for your predecessor successor, you can always be rooted, but you may require more number of hops. So let's see what happens. So 4, 2, 3, 5, you can actually arrange them in a circle so it becomes easier for you. So it is going to be 0, 1, 2, 3. So who is the next guy after this? Is going to be 4, 2, 3, 5. And after 4, 2, 3, 5, you will get 7, 7, 5, 3. And after 7, 7, 5, 3, you will get 8, 2, 5, 3. And after 8, you will get 9, 2, 3, 5. And from here you will get AB02. And then F220. This is how they will get organized in the chord. And of course you can count, these are 7 nodes. Yes, these are 7 nodes. So 4, 2, 5, 3 in the beginning, because there is no OM table, you have only a routing table. Okay, I am also assuming there is no neighbor table also here. Okay, so this is not a pastry, this is chord. So chord does not worry about the neighbor table, they are not required. Okay, this is only based on the numerical closeness essentially which matters here. So 4, 2, 5, 3 will now give a feed. These are the nodes participating in the DST layer for the overlaid multicasting. 4, 2, 5, 3 will give a feed to, we'll find out who are the neighbors. There will be 3 neighbors actually for him. Okay, so one will be 0, 1, 2, 3 obviously, other one will be 7, 7, 5, 3 you can see, and then diagonally opposite 8 plus 4 is 12, which is B, so which means F220 will be the next entry. Okay, so the beacon will be sent from here. So 1, 2, 3. So how the network connection essentially based on that. So the beacon will come here, here and here. They will be sending it to others. Okay, they will maintain a routing table, so duplicates are going to be there and they will be removed. So 0, 1, 2, 3 will be now sending this information beacons to whom? So 0, 1, 2, 3 will send it to 4, 2, 3, 5 back, discarded. Okay, it will be sending F220, discarded, it has already got the beacon. So NAC will be sent. So these 2 entries will not be there in the children list. Okay, and then of course third entry will be 0 plus 8 is going to be 8. So 8, 2, 5, 3. Yes, so this will be the entry which will be there. Next one. So I have made some mistake in my notes, but anyway, I am going to correct it here. So 0 plus 8, because it's a 16 digit, so I am going 2 raised to power n minus 1 is actually 8 in this case. Okay, so 2 raised to power 4 is 16, so correspondingly 8253 will be here. So this will be receiving the beacon, perfect. And then let's, all three has been exhausted. Now go to 7753. So 7753 will have 4235, it will give a feed back. So will be discarded actually, 7753. 8253 it will be doing. Okay, this way. Of course discarded, already beacon has been received from this route. And then 8 7s are 15. So F753, so it comes to 0 1 2 3, so this will be coming here. It will be discarded. Okay, then F220 once you come, so F220 shows that it has to go to AB02, yeah, which is a new node. This will be receiving the beacon. So red ones are the one which are discarded actually. Okay, F220 then goes to 0 1 2 3, which is here. So this will be discarded because this has already got the beacon. Okay, so this is discarded now. So F plus 8, 8220, so 8253. So next this will again be discarded. So all three has been exhausted. Only black one is the tree through which the beacons will be received. Rest everything is being discarded. Now come to 8253. 8253 goes to 7753 first, which is going to be discarded obviously. And 9235 does not exist. So we'll have 9235. And 8 plus 8 is 16, F253. F2, it comes to 0 1 2 3 actually. So this will be also discarded. This is already receiving the feed. Okay. This basically tree getting created based on routing table, beacons which are being passed. Some of them will be discarded. So now come to AB02. So AB02 will have, in fact we have already got all 7 now. So even whatever nodes you pick up, so I have already created all 7 nodes in the network now. Whatever link you pick up now, they are all going to be discarded. This is where the beacons will now travel. So this will be the final situation which you will have. And each one of them will now maintain an entry. So as for example, knows that it itself is the source. So this guy will know that the parent entry will be itself 4253. And children entry it will now maintain 0 1 2 3. It will maintain 7753 and F220. Okay, so depending on the reputation it will be happening. F220. So for F220 will have now parent entry is 4253 and children entry as AB02. In fact here you don't need to keep it, you say you are the source itself. Similarly AB02 will have only a parent entry, this will have no parent, only parent entry. This will have one children entry, this will have one children entry, only parent entry here. So this is how it will be. Now in this case, suppose somebody becomes a free rider, what is going to happen? 0 1 2 3 becomes a free rider, it does not give any feed. As a consequence, the reputation will go down. Okay, his reputation goes down, and meanwhile 8253 knows about 4253 or somebody else who is the parent of 0 1 2 3. So when it joined, actually that time it figured out. In between 0 1 2 3 created a problem. Becomes a free rider, does not want to give the outgoing link on this bandwidth, it does not have much money, for example. So in that case 8253 will now connect to 4253 to make a connection. 4253 will figure out that 8253 has got a reputation because it was giving feed to 9235, but 0123 is not giving any feed, so its reputation is going down slowly. So it will start giving it will throw this guy out, give him what are the sibling addresses 7753 and F220. So 0123 is out. So in that case a new link will get created now, and so new link will be, this entry will change, and now this is the connection. This poor chap now has to figure out somebody else, siblings are there, so it will connect him. It says I am anyway not gaining any reputation because I am not feeding, somebody is asking, so I will very happily oblige and it will make a connection in this fashion. This guy will be out, this connection will be out, and you get a new topology now coming in. So 0, 1, 2, 3 comes here, and this guy moves upgrade. Okay, this is how basically the continuous movement of nodes across the topology will happen, and OM table slowly will become different than your RT and NT. NT is neighbor table, this is routing table, and there is now overlaid multicast table. This will start evolving based on this exchange continuously. And ultimately topology will move in such a way that it will stabilize where the higher reputation into the number of layers, whichever has those nodes will move upward, and those layers which have this value is less value will tend to move downward. Okay, there is a dynamic reconfiguration which will keep on happening. So this is another way we can actually build a overlaid multicast. It's slightly different design. In this case, of course, it does not matter on your neighbor table, because of routing table the connectedness is guaranteed and over which we are sending beacons, and after that there is a dynamic optimization which happens. So this is a kind of a pretty much a stable thing. You will never get routing loops in this case, at least. So in the next video we will look into how the peer-to-peer mail transfer actually can be implemented. So that also is a part of the design for Brihaspati 4 which we have been doing. Initial code is there, but we have to essentially, the volunteers have to work on it and further make it, I think, a better quality code before it can be released. Thank you.